As you know, last week we were working on multiplication. This week we are going to move on to division. Division is what is called an inverse operation, which means opposite of multiplication, just like addition and subtraction are opposites as well. Multiplication and division also pair together as opposites and can help you understand facts better when you already have a basis for your multiplication. So we are going to use our multiplication facts to help us with division as we work through this standard. First, we are going to take a look at our success criteria, and we are actually going to be taking some notes on division vocabulary. So please grab your math notebook if you do not yet have it near, and grab something to write with. We will be taking some notes today on division vocabulary, so make sure you have that quickly.
Miss Lisa, I don't have my math notebook. That's what I was going to say.
Right. Remember, we do not need to share that we don't have something every time because you guys know the procedure. If you don't have it, you can find a piece of paper or you can copy it during your task completion later from Seesaw because I will upload it on resources. Okay, so if you don't have it, you'll need to write it on paper or copy it from Seesaw later, but you are going to need to hang tight for the lesson and still participate. Okay. Alrighty, while you are grabbing that, I'm going to go ahead and take a look at our success criteria for the day and some of our division vocabulary. Hey, third grade, welcome to day 1 of division. We're going to work on representing division using several different models and strategies, the same way that we represented multiplication using different models and strategies. Before we can jump into some of the models that are asked of us in our standard, we need to build some background knowledge by understanding that division takes a large amount and breaks it into smaller groups. Just like multiplication takes a small group and adds it over and over until we have a larger amount. They are opposite or inverse operations. Today, you're going to learn how to use repeated subtraction to divide, or how to take an item and put it into smaller equal groups. Some vocabulary that may be helpful for you is shown here in this graphic. In a division equation, we have 3 different numbers. We begin with the dividend. The dividend is the larger number that's going to be broken into smaller equal groups. The divisor is the second number in a division equation, and this number represents the total number of groups that will exist. The final number, the quotient, will represent the number of items inside of each group. All right, so we'll take a look at some of that vocabulary here in a moment, but first we're going to watch this Brain Pop Junior video on repeated subtraction so you have some more meaning and visual examples of what these words mean and what they represent. So without further ado, here is your repeated subtraction video.
It's snack time. Do you want to split this with me? There are 8 slices, and there are 2 of us. How many slices do we each get? When you divide, you take a larger group and split it into smaller equal groups. We can divide 8 by 2 to find out how many slices we each get. How can you subtract to help you divide? You can subtract a number over and over again to solve a division sentence. How many times can you subtract 2 from 8? I know that 8 minus 2 is equal to 6. 6 minus 2 is equal to 4. 4 minus 2 is equal to 2. And 2 minus 2 is equal to 0. We subtracted 4 times until we got to 0. So 8 divided by 2 is equal to 4. We can check our work by taking the 8 slices and making 2 equal groups. We each get 4 slices. Whoa, that's a lot of pizza. Some friends are sharing pretzels. There are 12 pretzels and 4 people. How many pretzels does each person get? You can divide 12 by 4 to find the answer. Subtract 4 over and over again until you get to 0. 12 minus 4 is equal to 8. 8 minus 4 is equal to 4, and 4 minus 4 is equal to 0. We subtracted 3 times, so 12 divided by 4 is equal to 3. Each person gets 3 pretzels. Who wants some animal crackers? There are 25 animal crackers and 5 people. How many does each person get? Divide 25 by 5 to get the answer. We can also write it this way. How many times can you subtract 5 from 25? 25 minus 5 is equal to 20. 20 minus 5 is equal to 15. 15 minus 5 is equal to 10. 10 minus 5 is equal to 5. 5 minus 5 is equal to 0. We subtracted 5 times, so 25 divided by 5 is equal to 5. We each get 5 animal crackers. What other strategies can help you divide? Becca is selling snack boxes to raise money. She wants to raise $12. How many boxes does she have to sell? Divide 12 by 2 to find the answer. You can use a number line to help you divide. Start at 12 and count back by 2s until you get to 0. We counted back 6 times. So 12 divided by 2 is equal to 6. She has to sell 6 boxes to raise $12. Related facts use the same numbers with opposite operations. You can use related multiplication facts to help you solve division sentences. To solve this number sentence, think of its related multiplication sentence. What number multiplied by 7 is equal to 14? I know that 2 times 7 is equal to 14. So 14 divided by 7 is equal to 2. You can also use a fact triangle to help you solve division sentences. What is 20 divided by 5? What number can be multiplied by 5 to get to 20? I know that 5 times 4 is equal to 20. So 20 divided by 5 is equal to 4. You have a snack you want to share?
Mrs. Ray, please come to the front office.
Is that cheese? Toe cheese. Ew.
Alrighty. We are going to take a look at some notes in our notebook regarding division. So please grab your notebook. I'm going to switch my camera view. And remember, you can pin my video so that it appears larger by going to your top corner and selecting pin. and also by going to the three dots and selecting, or the large screen and the two arrows that point out. You can go there as well. Alrighty, so I'm going to open up to the next page. Oh, I'm in my reading notebook. There we go. Next page after my multiplication notes. I'm going to move on to my next page, and we are going to take some division notes. So at the top, I'm going to put a nice title of division. There we go. And just like we did with multiplication, when we learn a new strategy, we will add it to this page so that when we are done with our lessons on division, we have a page or a little poster, mini poster for us on all the different strategies that we can use. So, working on division. Alrighty. So first, we're going to take a look at those three vocabulary words that we looked at the beginning. A dividend is going to be the number being split into smaller groups. A divisor is going to be the number of groups the dividend is splitting into, and the quotient is the answer. We'll stick with a familiar fact like we did for multiplication. We are going to start off with 12. And I'm going to make this take up 2 lines. That way, when I label the vocabulary, I'm able to see it more easily. So 12 divided by, in our multiplication fact, we use 3 and 4. So we'll continue on with that same grouping. So we're going to do 12 divided by 3 equals 4. So 12 divided by 3 equals 4. And first off, let's start with our quotient. Since we have some space over here, this number, our answer, is called a quotient. So I'm going to write that word quotient, Q-U-O-T-I-E-N-T, a quotient. The quotient is the answer to a division problem. So just like a product was the answer to a multiplication equation, a quotient is the answer to a division equation or a division problem. I'll give you a few moments to record that. And then we'll take a look at what that 12 is called and what that 3 is called. Question?
What happens if you change it to 4 division? 4 division, what if you make 12 divide 4? What do you get?
You would get the same number. You would get 3. So inside the fact family, the numbers are going to remain the same.
So you can switch
The
it.
relationship between them. Timothy, a question?
I just did 12 divided by 4.
Okay, same thing as Avon. All right. So our next number that I want us to understand is this first number, which is 12. The first number in a division equation is called a dividend. And I'm going to kind of draw an arrow to go down. And this is called a dividend. dividend. That's a funny word to say, a dividend. And a dividend is always the first number in a division equation because it's going to be the largest number. In division, the largest number will be first because we're taking a large group and breaking it down. In multiplication, the largest number would be last because we're taking smaller groups and putting them together. So in division, our first number is always going to be the larger number. So the dividend is the number being split into smaller groups. So a dividend is the number being split into smaller groups. Move my camera around there. There you go. Our last number is a divisor, and that is the middle number inside of an equation. I'm going to kind of draw an arrow off to the side here so that I have enough room. So you can do the same thing wherever it is that you have room inside of your notes. That's fine. So again, this is called the divisor. And the divisor is the number of groups that the dividend is being split into. So the divisor is the number of groups the dividend is split into. Today, the strategy that we are kicking off division with is repeated subtraction. Just like we started multiplication with repeated addition, we're going to start our notes today with repeated subtraction. So I'm going to move these notes up. If you did not finish, remember, I'm going to upload them to Seesaw. And during your task completion, you can finish these, okay? So give yourself enough space as you think you'll need. And then I'm actually going to draw a dividing line, just kind of a little squiggle. And then I'm going to put my repeated subtraction notes below it, okay? So we are getting ready to learn about repeated subtraction. So go ahead and label that. Repeated subtraction. That's the strategy that we are going to be reviewing and learning today and tomorrow. Repeated subtraction. So remember, division is making groups smaller, so we are subtracting. Multiplication was making groups larger, so we were adding. They are opposite or inverse operations. Okay. Repeated subtraction, we're going to stick with the same problem that we did earlier. So let's show our 12 divided by 3 equals 4. We already know the answer because I've given it to you, but we're going to show how to solve this with repeated subtraction. Okay? So with repeated subtraction, we are going to start off with 12. So go ahead somewhere that you have some space and put a 12. Let's see, I'll put it down here. No, it won't. Yeah, it will. All right, 12. 12. And we are going to subtract 3. 12 subtract 3. We know that 2 subtract 3 is impossible, so we've got to regroup this by borrowing a 10. So we have 12 ones, subtract 3 ones. That equals 9 ones. So 12 subtract 3 equals 9. We're going to start a new subtraction equation. So I'm going to draw an arrow up to the top to bring my 9 up here. And then I'm going to subtract the same amount again. We're dividing by 3. So 9 subtract 3. If I have 9 fingers and I subtract 3 of them, I am left with 6 fingers. So 9 subtract 3 is 6. I'm going to keep subtracting until I get down to 0. So I have 6 and I'm not at 0 yet, so I'm going to subtract again. So I'm going to bring my 6 up here this time. So now we have 6 minus 3. I have 6 fingers and I put 3 down. I have 3 left. So 6 minus 3 is equal to 3. I'm not at 0, so I've got space to do another subtraction sentence. This is going to be 3, and again we are subtracting 3. 3 subtract 3 is equal to 0. So now I don't have anything to carry up because I'm at 0. So now, in order to find the answer, because remember, we're pretending like we don't know it equals 4, I'm going to count how many times I had to subtract this. 1, and I like to actually circle 2, the subtraction signs, 3, as a way to keep track. 4. We subtracted 4 times, so the answer is 4. This is how you use repeated subtraction to solve an equation. William.
Isn't that just like 4 groups of 3?
Yes, this would be the same. There are 4 groups of 3, so if we were multiplying, we would know that 4 times 3 is equal to 12. So now let's write a sentence. Thank you for that connection, William. Let's write a sentence to capture that. We subtracted So we subtracted 3, 4, and I'm going to write out the word 4, that way it doesn't look like 34. We subtracted 3 4 times. So our quotient is 4. That's how we know what our quotient is, or our answer is, when we look at how many times we had to subtract until we got down to nothing left. Just like in the video when they were sharing the snacks. You don't want any snacks left over. They kept passing them out until they were all gone. So that's how we find the answer. This is going to finish our notes for the day, so I'll give you a moment to catch up on taking those notes. As you are taking those notes and catching up, I'm going to be uploading them to Seesaw so that you have them for your reference. So take a few minutes, finish writing that sentence down. Alrighty, that is loading to Seesaw. Let me rotate it really quick, actually. Oops. And we will put it inside of the math folder. Alrighty. If you did not have time to finish taking those notes, that is okay, because they are being processed and uploading to Seesaw now. So you will have the opportunity during your work time to get those. Oh, look, there it is. It's uploaded. All right, beautiful. So that will be on your Seesaw. Okay, for now, let's pause on taking those notes and let's come back together. I want to spend our last 15 minutes looking at some examples of what it means to show repeated subtraction. So we're going to take a look at that together. This is an interactive PowerPoint. As we're watching, I'd like for you to be thinking about the information and guessing or predicting what you think is going to happen next. Aidanelle, a question?
What kind of what kind of phone you have? Your phone.
Oh, that's not about our math. All right. So division as repeated subtraction, that is what we are taking a look at today. So as we've talked about, you know that addition and subtraction are inverse or opposite operations, just the same way that multiplication and division are opposite inverse operations. So we can use what we know about multiplication to help us solve division questions. So inverse operations are related as they are the opposite operations. When we multiply and when we divide, we use equal groups. So equal groups does not go away. When we're dividing, when we're sharing items, we still want there to be an equal amount so that we're fair, right? When multiplying, we put equal groups together, but when we divide, we break a whole into equal groups. So in multiplication, we ended up with the bigger amount. In division, we start with the bigger amount and break it down into smaller groups. We learned that multiplication is repeated addition. So we knew that 4 times 5 was the same as 4 groups of 5. 5 plus 5 plus 5 plus 5. We knew that that equaled 20. Now we're going to take a look at how division can use repeated subtraction, just like we showed in our notes. So we can use repeated subtraction to solve a division problem, just as we can use repeated addition to solve a multiplication problem. So 20 divided by 5 can be represented as 20 subtract 5. We know this equals 15. We're not at 0, so we would keep going. 15 subtract 5 is 10. We're not at 0, so we would keep going. 10 subtract 5 is 5. We're still not at 0, so we keep going. 5 subtract 5 is equal to 0. Now we're at 0, so now we're going to count how many times did we subtract 5. 1, 2, 3, 4. Nice. Terrence was showing the 4 with his fingers. So 20 divided by 5 does equal 4. Question is, why are we subtracting by 5? Because that's how big our groups are. Okay? So let's say that I had 20 candy bars for Halloween, and there were going to be a certain amount of trick-or-treaters, and I wanted to give them away in groups of 5. So here's a 5-pack for you, a 5-pack for you. I could do that 4 times before I ran out. So I would be able to help 4 trick-or-treaters, okay? So we subtract by the number that we are dividing by, and that tells us how many times we're able to do that. So let's try another one. 16 divided by 4 is the same as 16 minus 4, which equals 12. We're not at 0, so we keep going. 12 minus 4 is equal to 8. We're not at 0, so we keep going. 8 subtract 4 is equal to 4. We're not at 0, so we keep going. 4 subtract 4 is equal to 0. Hey, we're done. So how many times do we subtract 4? 1, 2, 3, 4 times. So our quotient is 4. Here's another way. 18 divided by 6. We're going to start with 18. We're subtracting 6. 18 minus 6 is equal to 12. We're not at 0, so we keep going. 12 minus 6 is equal to 6. We're not at 0, so we keep going. 6 minus 6 is equal to 0. Hey, we're all out. We've passed them all out. So now we count. How many times do we subtract 6? 1, 2, 3. So our quotient is equal to 3. Here's another way to show division as repeated subtraction, and it's the way that we did in our notebooks. If going up and down like this is confusing to you, for me it is, especially if I need to borrow, so I like to do them sideways. You can do it either way, and it will still give you the same answer. So we're starting with 21 minus 7 equals 14, so we put the 14 up top. 14 minus 7 is equal to 7, so we put the 7 up top. 7 minus 7 is equal to 0. So, what division fact is shown by this model? We started with 21. We subtracted 7, which means we are dividing by groups of 7. So I start with the whole amount, 21. I subtracted 7. How many times was I able to subtract it? 1, 2, 3. So this division equation is 21 divided by 7 equals 3. Let's look at one final example. Think about what division fact is shown by this model. 18 subtract 6 is equal to 12. I've noticed I'm starting with 18. I'm not at 0, so I'm going to add 12 subtract 6 equals 6. I'm not at 0, so I'm going to go to 6 subtract 6 equals 0. So now my question is, when I divide, I start with the whole amount. How many did we start with? 18. How many do we subtract each time? Minus 6, minus 6, minus 6. So that would be divided by 6. How many times do we subtract that number? 1, 2, 3. So 18 divided by 6 is equal to 3. That is how we would represent this with division. Okay, allow me to skip forward a little bit here. When we look at this on a number line, it's the same thing as multiplication, except we're working backwards. So when we show repeated subtraction on a number line, we're going to start at 24, and we're going to count back by 4 until we get to 0. On multiplication, you counted forward because you were adding. On division, you will count backwards because you are subtracting. So 24 divided by 4 is equal to 1, 2, 3, 4, 5, 6. We subtracted 4 6 times. So this is how it looks on a number line. Now we're going to divide 24 by 8. We're going to start at 24. We're going to count back by 8 until we get to 0. 1 time, 2 times, 3 times. We subtracted 8 3 times, so 24 divided by 8 is equal to 3. Okay? So when we're on a number line again, we're going to start backwards. So let's take a look. We started at 12. We counted back by 3 until we got to 0. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. We did that 4 times. 1, 2, 3, 4. So 12 divided by 3 is equal to 4. Same thing here. We're going to start at 20. We're going to subtract 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We did that 4 times. 1, 2, 3, 4. So 20 divided by 5 is equal to 4. Okay? So this is how we would represent repeated subtraction when looking at division. All right? Today, you do not have a seesaw task. We threw a lot of information and a lot of vocabulary at you, so I want you to be comfortable with that division vocabulary before we look into some book work. Tomorrow, we're going to be looking at how to solve division with repeated subtraction, and you're going to be creating some problems.